So for the uninitiated, what is 3D printing and how does it work?
I've created OctoPrint, which people familiar with 3D printing might have heard of, and been working on this full-time now since 2014. So this year it will be 10 years, and fully crowdfunded since 2016 as well. So
how has 3D printing evolved over the years?
Feasibility to buy one. So do you think the cost has also decreased so not common people can afford?
So what would be a good entry point for someone that just wants to get into 3D printing? Like you're saying, don't buy the 150 euro ones, but they're not quite as expensive as 1,000 euros anymore. Like where's kind of the price point where a beginner can get in safely?
The thing is that you will have to learn some stuff. So it's not like you can just buy one of these and then start creating your own models and immediately have the most amazing things printed ever. When I say 3D printing has taken over my life, I literally mean that it's become my job, or rather working on software that drives 3D printers has become my job.
What's the junior dev version of 3D printing? Is there one, or do you kind of
hard to say?
Welcome back, everyone, to another episode of This is Tech Talks, episode 13. Today we have someone here to talk about something that we haven't really spoken about before. Usually we're talking more about software and coding and stuff like that. Today, it sounds like it'll be a little bit more on the hardware/physical side of the world that we live in. But I'll let our guest introduce herself, because there's a 100% chance that I'm going to butcher her name because mine is so easy and I already know how to pronounce Santosh's.
Yeah, so hi, my name is Gina Heuske, and yes, that is indeed an S in there and not a B. But you can also refer to me as Fusel, which is probably what I'm best known around the net as. And yeah, thanks for the invite, and I'm happy to be here and talk about 3D printing and 3D printers in general, which took over my life about 12 years ago or so. So yeah.
Cool. I see there's a GitHub star in your background, just like Santosh has. So do you do a lot of coding then as well? And you're just like 3D printing for fun? Or
no, so the thing is that back in 2012, I got myself my first 3D printer, and it was sitting here in my office and producing noises and fumes, and this annoyed me greatly, and I wanted to get it out of this room and into a spare bathroom, in fact. But I didn't want to lose this connection to it, to know what it does, because these things are anything but plug and play. You really want to keep an eye on them. And so I figured there must be some software that allows me to remotely monitor and control it, right? Turns out there wasn't. So I wrote it myself. And this is pretty much what I've been doing the past 12 years. I've created OctoPrint, which people familiar with 3D printing might have heard of. And been working on this full-time now since 2014. So this year it will be 10 years, and fully crowdfunded since 2016 as well. So when I say 3D printing has taken over my life, I literally mean that it's become my job, or rather working on software that drives 3D printers has become my job.
Cool. That's really cool. I did a little bit of 3D printing when I was in university. When I was in the engineering program, we got to do a couple engineer a product that isn't on the market, and then you can go and use the 3D printers, and it was pretty cool, pretty fun to use. So for the uninitiated, what is 3D printing, and how does it work? Like what exactly are you printing from, and are you printing, and are you printing, or is it building? Give us
You're printing. So it's called printing, even though it doesn't necessarily have much to do with your random laser printer or something like that. So imagine a hot glue gun, but a hot glue gun on a CNC gantry. So a hot glue gun that you can move in X, Y direction, and which you can also move up and down in Z direction. And now imagine building a 3D object with this hot glue gun by basically drawing it layer by layer. So you extrude hot hot glue on a build level, on a level build plate, and then once this first layer has cooled down, you move a layer up, do the same, and by that you build up the model. Now, a 3D printer, of course, does not work with hot glue, but instead with spools of filament, which is basically 1.75 millimeter with plastic wound up on a spool, and usually that is either PLA or PETG. PETG is something that you might know from water bottles, or ABS, think Lego bricks, or ASA. So there's a bunch of stuff that you can print with. The most common stuff probably, though, is PLA and PETG. And the nice thing about PLA and PETG is sitting next to it when you're printing, you do smell it, but it's not as bad as when you print ABS, for example. Because the idea here is similar to a hot glue gun. You basically force this cold piece of plastic wire through a so-called hot end, which is basically a nozzle with diameter between 0.4, most commonly 0.4 millimeter up to maybe 1 or something, and melt the plastic in the process, and then you get a really small, really tiny amount out of there, and with that you print. And your model, what you are printing, your 3D model, will be built up out of layers as well, like with the hot glue gun analogy. And you, depending on how thin you make your layers, you will be able to actually see these layers as well and feel them. That is a bit of, the standard thing, how you identify 3D printed stuff. And this is one way of 3D printing things, and the most commonly, let's say, consumer kind of way. There are other things that you can also do. There's powder-based 3D printing, where a laser sinters the layers, the individual layers, basically melts them together and then builds up from that. That is stuff that is used commercially, for example, for rocket engines, or for flight stuff and such. There is also optical approaches where you use some stuff that hardens when it gets UV light on it, and then you basically harden it layer by layer by layer as well, which gives you very, very tiny layers and very, very fine detail at the cost of handling very, very toxic materials. So the thing most or best working in a common household is probably this hot glue approach of building up stuff layer by layer from molten plastic, and that is also what I primarily use. I have one of these UV hardening stuff printers as well, but it is a bit of a mess.
Wow, yeah, okay, crazy. Well, that's a lot to know, for sure. I'm assuming there's, like you were saying earlier, they're not exactly plug and play, but is there an easy way for someone that just wants to learn about 3D printing to get into it? Like, what's the junior dev version of 3D printing? Is there one, or do you kind of got to
say?
Jump?
I mean, the thing is that you will have to learn some stuff. So it's not like you can just buy one of these and then start creating your own models and immediately have the most amazing things printed ever. So there is a learning curve that you have to expect. You have to learn about the tooling, the involved tooling. You will also, if you are already into 3D modeling, you will have to learn how to model specifically for 3D printing. Because if you look back at this hot glue analogy, imagine something that is shaped like an uppercase T, like the things that are on the side. If you would try to print them that way by just putting layer upon layer upon layer, they would just go down and not work and stuff like that. And there is the option of creating support material, so-called support material. Basically, you along with the model itself, you also build a support structure that will hold up pieces like this. But in general, when you model a piece specifically for 3D printing with this method, you will also try to keep in mind certain things that will allow you to print it with the least amount of support as possible, because of course support structures take time, and removing them also takes time. They take up material and effort, and it never looks as good as it would without having to use support. That is also the problem.
Yeah, that makes a lot of sense. I know I've seen a lot of, people just post on the internet and stuff like that, all these like crazy structures with like wild amounts of supports, and then like they have to go and clip and shave and clean afterwards. It just takes so long. How has 3D printing evolved over the years? Like obviously the tech has gotten better in recent years, but has it gotten like significantly better? Because the last time I did it would have been like 2014, maybe 2015. So like that's a lot of time for it to innovate and get better.
Yeah, the basics haven't changed though. The thing is that we still usually have something like 3 to 5 maybe stepper motors that control all these movements of the various axes. We still have the same style of filament. We still have no closed loop system, so to speak. So if something stops the printhead mounted to the stepper motors from moving into a one direction, the system will not know about this, and everything will be offset and the print will be ruined. Things like that. What has gotten a lot better though is we've gone from 8-bit controllers to 32-bit controllers. We've gone through several iterations of firmware, better secure or not security, but rather safety features in firmware that will detect if there are thermal issues, ways to detect problems with the motion system, to detect and also work around things rubbling. No, wait, rubbling is the wrong word, but like getting into this whole wave stuff.
Right.
Also something that was still quite uncommon when I started with 3D printing in 2012, and I'm not sure if it might have become more common by 2014 when you were looking into that. But we did not used to have heated beds. The thing is with plastics, when they cool down, they contract. And when you try to glue something on a print bed in a hot state and then it contracts, then it will loosen up if you're really unlucky. And if stuff loosens up while you're printing, then stuff once more offsets and everything is ruined. These days, or maybe let's say the past 5 to 6, 7 years or so, I think I've not seen a single 3D printer that didn't come with a heated bed out of the box, and that has helped a ton. And also the thing with leveling. So in order imagine you are printing with something like 0.2 millimeters layer size, so really, really tiny. Like you can put a piece of paper in between, and it will catch on the nozzle thin.
Right. Yeah.
And if the printhead is not moving in the not exactly parallel to the print bed, then sometimes you will get way less than 0.2 millimeters, and sometimes you will get way more than 0.2 millimeters, which once more means you are too far from the print bed. Your print will no longer stick. Things will offset. Things will be ruined. And in order to compensate that, these days it's also very common that you have so-called auto leveling, which in fact is a bit of a wrong word because it's actually auto tramming. Which makes sure that your printhead actually is kept parallel to the bed. So before the print starts, the printer will probe where the bed is, create a bit of an offset curve for that, and then we'll make sure that it stays parallel to the bed at all times. And that has also greatly improved results.
Yeah, the heated bed makes perfect sense. I have a feeling that we didn't have heated beds back then, But makes perfect sense. If you put something hot onto something cold, things aren't going to work correctly, right? So I'm assuming with heated beds, then once the printing's done, the bed will gradually cool down. Kind of, it's built so they'll cool gradually, so that it cools at the same temperature as the plastic, and then kind of settles.
You usually also print on something called PEI, which is also some kind of plastic, and that has specific, so that is So basically, if you extrude PLA or a PETG onto hot PEI that way, then it will stick really, really, really well. So well, in fact, that sometimes it can get a bit problematic to get it off again, even if the plate has cooled down, which is also an innovation over the past, let's say, half a decade or so. We now have print beds that are just stuck to the printer with a very strong magnet, with a heat resistant magnet, because you have a hot print bed, which you can then take off and just like bend, and then stuff just pops off, and that makes it way easier. I remember in the early days, with a cold heat bed, that I had to put painter's tape on to give it the structure that the plastic could somehow hold on to. It sometimes held on so well that I had to take like not only a knife but actually a hammer to it to get it off again, and then the tape would sometimes still be stuck on it, and it would be in horrible work to get it off. So things have improved a lot in that regard.
It sounds like they've gotten a lot better than just 10 years ago, kind of thing. Obviously, it's still not a perfect
Absolutely.
science, it sounds like,
Absolutely.
right?
I mean,
but
it's also, you can now buy filament on Amazon. I remember times when I had to order it in like the Netherlands or in UK because I could not get it here in Germany. And
yeah.
So one question from my side, Gina. So of course we are saying okay, it has improved a lot over the years, but what about feasibility to buy one? So do you think the cost has also decreased, so not common people can afford?
It has actually been a race to the bottom. Like at some point you could buy a printer for 150 euros. It was not a good idea to buy one for 150 euros, but we had situations where they cut really every single, so the company selling these things, cutting every single corner, removing all of the safety features from the firmware because their components were really crappy, with the result that sometimes these started to catch fire. And so for my first printer, all in all, I think I still paid something like 1,700 euros. And these days you can definitely have them for way, way less than that.
You have to be careful, right? I mean, of course.
Yeah, you should not you really should not buy the really cheap stuff, as with everything.
Especially electronics and things that are like not just regular electronics. Like definitely don't buy a cheap cell phone charger because it's just not going to work very well. But like don't buy something that's going to literally start a house fire.
Exactly. And imagine a 3D printer has heating cartridges in there for both the print bed and the hot end, and the hot end is regularly expected to go up to 300 degrees Celsius, and that is when it is controlled. If it just for some reason, because some sensor broke or the firmware got stuck or something, if it just continues to heat up, it can melt aluminium. So you really do not want that. So don't skimp on the safety of your stuff that you buy. And actually at some point it got so bad that I started collecting some information from the community and built something into OctoPrint that would detect if the connected printer was unsafe,
right,
and show a big red warning to people then, which has gotten me a surprising number of complaints from people who did not like me telling them that their printer is unsafe. And
Oh.
Well, you know what? Those people will always find something to complain about, I think. So
absolutely.
I wouldn't worry about them too much.
I don't. I just found it funny. Like, I'm telling you, your printer might burn your house down, and the first thing that you do is complain to me that it is not something that I should be telling you, because I don't know. Like, people are weird sometimes.
Agreed. Absolutely. So what would be a good like entry point for someone that just wants to get into 3D printing? Like you're saying, don't buy the 150 euro ones, but they're not quite as expensive as 1,000 euros anymore. Like where's kind of the like price point where a beginner can get in safely?
I would probably, so I have to admit that I'm currently a bit out of the market with regards, so there are so many models being thrown on the market at the moment, and so and stuff is phasing out so fast as well. Not in a way that they are innovating at all. It's just like they are just pumping out models and then moving them away again half a year later to pump out the next version. It's really weird. But in general, I would start to feel safe around 300 to 400 euro, something like this.
That's not too bad.
Right. I mean, it is a hobby. You should be aware that you're buying a tool that also comes with a hobby. It's not like
in terms of hobbies, 300 euros isn't really that much, though. There's some hobbies that cost
that is the
a lot
printer.
more. Yeah, true. That is only one part of it. That is true.
Then you start buying filament, and then you start buying nozzles, and then you start buying new hot ends, and you print new parts for your printer, and then you rebuild parts of your printer. And so the rabbit hole goes deep with this.
Hey, I
sometimes you also create software.
So I have no ground to stand on for telling people to not spend lots of money on their hobbies. I buy collectible cards all the time. So yeah,
I have a
I've
Lego
gone
habit.
down that rabbit hole.
Yeah, it's just what you should really be careful a bit about, and which is getting surprisingly difficult currently, is there is a clear push currently in the market for basically vendor locking you into some cloud shit and stuff. Like there's a bunch of proprietary options now. So I should maybe add that all of this 3D printing stuff that has become more or less mainstream over the past, when did this start? Let's say maybe 2009 or something. I'm not entirely sure when it started going all whoa, but that all of that was an open source thing. Some patents ran out, and then people started looking into if they could implement this whole approach to 3D printing, this putting plastic down on layer by layer. If they could do this with household electronics, with a bit of tinkering, with wood and whatnot, and they succeeded. And from all of this, all of the current market basically has developed. Like 3D printing, the 3D printer you buy at the hardware store has nothing to do with the 3D printer in the industry. First of all, not with the price, because in the industry we are talking about, I don't know, 500,000 or something. Whereas, as we just saw, we talk about something like starting at 150s. And all of that has been built on open source principles, open hardware. All of the designs were shared. There's this whole project around creating open 3D printers called RepRep, which you can find on reprep.org, REPRAP.org. And from there also, things started like open source firmware, and pretty much all of the printers out there still run on open source firmware. But these days some try to hide this fact and basically lock down the machine that they sell to you. And that is something where I would be very, very careful. There's currently one vendor on the market who is, the machine itself is pretty much amazing, but they are very, very focused on their cloud stuff. And there has also been a security issue in, I think, last year or the year before, where printers in people's homes randomly started printing at night because of a security bug. So that is stuff where I would really think long and hard whether I want to be bound to a specific vendor, or if I want to rather have a printer that I can use with whatever tooling I want, with whatever firmware I want.
So what would be, do you have a suggestion for someone that would, like a
Actually, no.
machine that's more open?
Actually, no, because even the people who I thought would stay very, very open are currently moving towards this cloud vendor lock-in stuff. So at the moment, it is really, really tricky. I never recommend anything either way, because the problem is then someone will say, Gina from OctoPrint said that this printer is good, and then I will be at fault if for some reason it isn't. And I really do not want to risk that. But yeah, so right now it's really, really tricky to not end up with something locked down. So I would really suggest, if you want to buy yourself a 3D printer, do a lot of research first. Figure out what kind of mods you can add to what you are looking at, if what you're looking at can be unlocked, if what you're looking at requires cloud, the vendor's cloud, or can work with with the open source options. If you can use it with whatever slicer you want. The slicer is the thing that turns the 3D model file into the commands for the 3D printer that it then runs through. Because a ton, especially the big vendors, are currently doing desperate efforts to try to get people to buy into their cloud systems, and it's a bit of a worrying development, I have to say, for someone like me who is big into open source and prefers to own her machines instead of renting them.
So basically, they also want to know what you're printing so they can sell you more, probably.
Yeah, and they even start now launching, all of them are launching their own model sharing platforms. And then there are also some issues with IP, and it's a weird situation. 5 years ago, it was a ton of fun. Before that, we had this whole situation where someone printed a gun with it, and then that was all people talked about. But maybe like 5 years ago, it was really a good point in time. Currently, the push to all of this lock-in stuff is worrying, to say the least. And I really hope that the community will vote with their feet and not go along with that stuff. But I don't know.
Interesting. It's an interesting market for sure. And like, I can't say I'm surprised that it's moving to the vendor lock-in and closed doors. I mean, that's just unfortunately how capitalism typically ends up working, and open source has up until now been quite at odds with that, right? It's something that we struggle with as open source contributors pretty much on a daily basis, right? So I can't say I'm surprised. It is sad, but I'm not surprised at the end of the day.
I'm not surprised either. I'm just maybe surprised how well the community is taking that, and that they are so basically how happily they will swap their freedom for shiny plastic and funny screens and whatnot. Like,
that's just consumers.
but it's a bit sad. I mean, there used to be a time when if a 3D printer, or rather if a vendor did not release the design faults for the 3D printer, they would have issues and basically a shitstorm with the community on their hands. And now it's basically the opposite, and it's weird and a bit sad.
Yeah. Do you think like making it more affordable has led to this, because now more people can afford, who don't want to get into more detail, like how does this thing work? They just want the 3D printer because it's cool.
Probably, yeah.
Yeah, that makes sense. So what are some of the applications or kind of general use cases for 3D printing? Like, what are people 3D printing? What kind of things do people 3D print?
So you of course have you have the people who print a lot of like Pokemon figurines and other stuff that they put on their shelves, but something that is also, or maybe also parts for board games, or for Warhammer or something like that. But there's also, of course, a lot of people who basically are printing stuff, functional prints. Like I, for example, have all of my network hardware mounted to something to a system that is like a pegboard but in hex shape, and where you can just download parts to attach other parts to there, and so functional prints or replacement parts, or like, I don't know. I have a bunch of parts that I designed myself on my bike for holding my 2D locks and for holding my radar unit to the back of my bike, things like this. Organization bits. I'm currently looking around if I have anything 3D printed in reach, but the only thing I have right now are like these 2 bins that I'm printing for my for organizing some stuff in the kitchen. But you basically, I think, can see a bit of a split between people who primarily concentrate on functional prints, including mods for the 3D printer, which can become a hobby in it of its own.
Mm-hmm.
And then, of course, also people printing more like artistic stuff, articulated dragons, eggs, whatnot.
That makes sense.
The funny thing is, once you get yourself a 3D printer and also get a bit into 3D modeling, you will realize that you approach problems that you face in your real world, in your day-to-day, with a slightly different approach, because then suddenly it would be so nice if there was something like this turns into, hey, I could maybe design that. And boom, project. And then you start drowning in projects.
Yeah, I got enough projects I'm drowning in. I don't think I need to introduce anymore.
I know the problem, yeah.
Yeah. What are some of the challenges and limitations of 3D printing with, let's say, with the technology that we have now?
Yeah, well, first of all, the reliability is still an issue. You still have the problem that sometimes your filament tangles. So it comes on the spool. If there is a knot on the spool, then stuff can go really, really wrong, and you lose hours of print time and material. You also still have the problem that apart from the filament tangle, the stuff that I mentioned, where we do not have a closed loop system. So if for some reason the print head snags on the model, for example, or for some other reason it gets offset, there is no way for the system to know that, and the print will be ruined as well. I just lost something like 1.5 kilos of carbon filament the other day because of that, so that was fun. And yeah, so there is still a lot of stuff that can be improved in the day-to-day, so that you really we are still a way off from it just being a fire and forget kind of thing. You still want to make sure that the first layer goes down nice and flat, and that it holds. You still want to make sure that your filament doesn't run out, that your filament doesn't tangle, and all of this. And there are approaches to solving all of this. There is AI detection through webcams that detects if something goes really, really wrong, tangles or something. There are sensors that detect if the filament runs out, but all of this is still not 100% working well, I have to say. There are still false positives and false negatives, and there is still a lot of stuff to improve with that regard. So you really should not go into this imagining that you will just send a print job there and 3 hours later you can go and pick it up and everything will be fine. Always. I mean, with a good printer, that will be the case in 80% or 90%, maybe even of the time. But then there are the 10 or 20% that will cause you a lot of headaches.
Yeah, I don't think we're not quite there. I've never heard a single person that's in the 3D printing, hobby space that's like, oh yeah, it just works every time. No one's ever told that, ever.
I mean, there are people who claim that, but I would say they are probably lying.
Yeah. I mean, yeah, fair. Nothing's 100%, let alone new, comparatively speaking, technology, right? Like 3D printing, especially one that's new to like the hobby market, right? Like we're still kind of in that like indie hacker type, like advanced hobbyist type realm, right? We haven't gotten to the like consumer can go to Staples and buy a 3D printer and bring it home and print a thing in a couple hours. We're not
I mean,
yet, right?
they can go to for a while at least, they definitely could go to a hardware store and buy one. I'm not sure about Staples.
Yeah.
But in general,
me.
There used to be a time when people, or when the media was all like, yeah, there will be a 3D printer in every household and yada, yada, yada. And that is just no, and this will never happen. It is a tool.
Yeah.
Not everyone needs this tool. And it is a tool on the level like a laser cutter and the CNC router, maybe with a bit of less dirt that it creates, and therefore a bit more accessible. It's definitely easier to put a 3D printer into a room than it is putting a laser cutter or a CNC into a room, because you always have to think about all of the stuff that happens around the creation process with like smoke and chips and whatnot.
I will give 3D printing that. It is easier to fit in a room than a CNC machine for sure.
At least if we talk about this FDM approach, which is the melting plastic. With when it comes to the whole other stuff, things get really, really horrible.
Oh yeah, absolutely. Okay, we talked a lot about 3D printing. Let's talk a little bit about OctoPrint before we have to wrap up here. What is it? How has OctoPrint helped the 3D printing industry? You said you've been working on it for quite a while now. So like, what have you accomplished with OctoPrint, and like, what's the like core value prop of using?
So when I started doing all of this about 12 years ago, what you did was you tethered your 3D printer to your computer and let your computer feed it data over a USB cable all the time. If you tripped over the cable, your print was gone. If something just wiggled on the cable, your print was gone. If you fired up, I don't know, Doom or something to play around, and because of that, the system resources were becoming a bit tight, your print was done. If your system decided to update itself and reboot, your print was done. That was a bit of an annoying situation. Back then, yeah, SD card accessories for printers were something that you had to actually buy as an add-on if you were lucky enough to even be able to do that. So in that case, you would put your files to print on an SD card, put that into your printer, and then via a menu and the display and all of that. So that was not standard back then. And what I created with OctoPrint was an approach that would allow you to manage the files that you wanted to print through a web browser, monitor your 3D printer through a web browser with an embedded webcam, being able to see the temperatures it is at, being able to start prints, monitor the progress of them, intervene if you saw something going really, really wrong on the webcam, and then even also, just being able to remotely watch it from time to time just to make sure that everything was going right. That was the initial minimal build that I came out with, let's say in January of 2013. And from then it exploded. A lot of people apparently had the same issue that I had because they really loved this idea. I had built it so that you could put it on one of these really, really small single PCB computers like the Raspberry Pi. So you would just buy one of these for $35 and then slap OctoPrint on that and a Wi-Fi dongle. Back then the RPi did not have Wi-Fi built in, so you still needed a dongle. And then you could just put it basically in your garage or somewhere else and let it do its thing and keep an eye on it remotely. And that was really nice. And then things continued to go, and more features were requested. And at some point, I also added a plug-in system, and that really, I think, made it explode as a platform, basically, because now people were able to build their own feature sets, were able to build their own notification systems into it. So basically, your print is done, you get an SMS or something like that. Or while your print is gunning, it pushes you pictures of the ongoing print job regularly via Discord or Slack or something like this. All of this was possible. People built nifty time-lapse approaches where it would look like the print was just growing out of the print bed without anything else moving. AI problem detection was also something that came in, switching off lights automatically when needed, fancy, colorful status bars built right into the printer and such. So basically people got really, really creative once I put in this plugin system. And so what it basically did was, I think it created the first platform for controlling your 3D printer for free, completely local. So there is no cloud component there. It's all on your own system. And if it cannot access the internet, the only thing that will happen is that it cannot update itself. But otherwise, you are in full control, and you are the one who decides what goes and what goes not. As I said, I also added stuff like safety checks. I added stuff like sanity checks for the files that you upload, because we saw some frequent error issues with that in the community, where some leftover placeholders from one slicer somehow managed to make it over into another, and then the print would fail because there were parts in the code that it would not understand, and then once more cause waste of time and effort. And yeah, so that is basically it. So people once, someone once called it basically a baby monitor for your 3D printer. And I think that sums it up fairly nicely.
Yeah, great. Well, that's an awesome note to end on, because I feel like a lot of people that are getting into the 3D printing, space, the hobby, want to be able to know that things are going to work correctly, right? And this sounds just like an awesome tool to help with that, right? Which
you really need that. Like, you really just don't want to. I have that with my UV printer, that I really have to play sneaker net and walk over there to check on it, and it is so annoying. Like,
yeah,
it's so much nicer if you can just whip out your phone and quickly check.
Yeah, absolutely. Awesome. Well, really appreciate it, Gina. This was super enlightening. Do you want to promote anything before we close off? We talked about OctoPrint, but where can we find OctoPrint? Where can someone?
Yeah, so that would be octoprint.org. And the only thing I would like to maybe promote here is, if you who are now watching and or listening to this have been using OctoPrint for several decades, and not several decades, 1 decade or whatnot, and are really, really happy with it, then maybe consider supporting my work on it, because I'm 100% crowdfunded. I work on this full time, and I need basically financial support from the user base in order to keep doing that. So yeah, there are all of the options in order to do that are also linked on octoprint.org, as is the community forums, the Discord, the GitHub repository. So yeah, everything Octoprint can be found on octoprint.org.
Amazing. I love it. Well, thanks again. Thanks, Santosh, for being here to talk to Gina with me. And we'll see everybody next time on episode 14.
Sure.
Oh, I think Santosh froze.
Yeah, he did. But the recording is still running.
Yeah, we could always edit it out. I don't think I can stop the recording, so we need Santosh to come back.
But that is what he's moving again.
There you go. You're moving again, Santosh.
It was my internet. So sorry. I don't know why it moved from LAN to Wi-Fi suddenly, but
we can stop the recording then, and we'll just have to edit the last little bit out.
Yeah, sure. I mean, yes, just to add, like, we will be back in another episode. So in next episode, we'll be talking about DevOps in 2024. So looking forward to the next episode. And thanks again, Gina, for joining us. All the links which you have shared, or all the links which we discussed, is in the notes. So you can always go ahead and refer to those. And thanks again. See ya. Bye-bye.
Thanks for having me.
Bye, everyone.